Okay, so we're now interested in making um, both vias and fiducials for this. So let's go ahead and do a via, and I'll go ahead and do file new. And again, I'll call this just a test for now because I don't know the dimensions of everything for the via yet. Default pad stack here is a circle. And let's do the one we talked about in the video. So we're going to do it where we had the 1 mm trace. And remember, what we wanted to do was say that the diameter then of the hole, well, 1 mm trace, we wanted to say that the circumference of the hole was equal to the trace width. And so we say if we have a 1 mm trace width, we want that circumference to be the same. So if I did 1 divided by 3.14, remember we got 0.318. And we went ahead and rounded down and got 0.3 millimeters for our drill hole size. So if we did that, we would go here and do drill. And you can do 0.3. I mean, that's a very typical via size. As I said, for our class, for manufacturing purposes, we won't be able to manufacture a hole that small. But again, if we had a laser etcher, we would be easily able to do a 0.3 millimeter via. Problem is once you have them, then how to plate them. If you don't have some kind of plating system, like an electrochemical plating system. So, but moving forward here, we now know that a via, we have to have both a top layer and a bottom layer. There does not need to be any kind of internal layers for a via. And so we need to come up with the pad here. Now this is where we have to be careful. And I'm going to possibly bring up here. Let me open something here and bring it over. I don't have my stylus to actually write right now with it, but I'll hand draw it here in a second. Um, so well, let's just go ahead and actually scroll back up here for a second. The 0.1 plus 0.6, that's what I was looking for here. So let me get down here further. All right. So we have this 0.3. And then we're going to do this plus, actually it's going to turn out okay for me here in this case. Plus 0.1 plus 0.6, which is equal to 1 millimeter as far as the radius. Now, the reason I was pointing that out, let me do another example. Suppose our trace width instead, I'm just giving a for instance. So just imagine if the width drawing with mouse is not ideal. I don't know why I'm trying to draw this. I should have just typed it out. But suppose, in fact, let's just type this out. Suppose the width is equal to the trace width is equal to 1.1 millimeters. And then you get that you are going to do a pad, a regular pad, because you can, doing your computations, you're still going to draw a 0.3 millimeter hole, and then you say, oh, well, the regular pad is going to then equal 1 millimeter. And actually, that says 1 meter, 1 millimeter. That's going to be a huge problem there, and it will never work. The reason is what's going to happen here, and let me see if I can actually draw this. So here, I have my trace here. So this is my 1.1 millimeter wide trace. Then I have my hole that's like 0.3 millimeters. That's drawn like right in there. And then that 1 millimeter etch, it's actually going to etch this green line 1 millimeter around that via. So now what it has done is it has etched away. There is no copper here. So let me, where there's copper, there's copper right here, and there's copper, inside here, but that green has had the copper etched off. And so if you've got the copper etched off there, um, that creates a problem. So we need to be careful sometimes with the vias and the size of the vias there. So just keep that in mind, but it looks like we're going to be fine with that no matter what here. And we're not going to get too much into the advanced vias. As I said, I'm going to finish this example with it, and then we're going to have you do one in the homework with a little bit more specifications I'm going to give you, and then that's the one we're going to use for design purposes. And it's going to be a really big via, but it's just for simplicity's sake. So let me close that out. So for this circular, we computed that the diameter would be 1 millimeter. But I'm not going to be doing any whoops, I said it as a square. I don't know why I did that. Circle. 1 millimeter. But remember, we're not going to put any internal layer here. Now, the thing that we have to, again, recognize here with a via, where I was going to say this, where I was going to go with this here. Oh, that just because our trace width might, like that rule of saying, well, let the circumference of the hole equal the trace width. Well, trace widths can actually get pretty darn small. And so like you could have a trace width, and I'm not exaggerating about this, but of like, let's say, 0.2 millimeters or something like that. And if your trace width was that narrow, you wouldn't want to use then the whole saying it's like, well, if it's 0.2 millimeters, then we really would then just go with a hole then that's, got a circumference of 0.2 millimeters and everything. We've actually kind of at the minimum hole size you would ever want for a via. I think you can go down to like 2.5 millimeters. And again, there are exceptions for high density boards, but in general practice, for general purpose boards, you don't go much below 0.25 millimeters for a via, and 0.3 is a very standard value for a general purpose board. Now, high density boards have all sorts of rules, and typically with high density boards, you're also talking about high frequency signals, and so there's all sorts of special accommodations you have to make when doing layout for those types of boards. All right, so let's go ahead and save this. What did I not do here? Oh, it said no internal, it's a warning, so you don't have to do that one. It shouldn't have brought that up. That's probably because it's an old version here. Drill figure not, size not defined. Cancel. Oh, yeah, I forgot to define that. Circle 0.3. I'm like, wait a minute, I defined it, but clearly I didn't. Now it's still going to give me this warning, no internal pads are defined. It says when no internal pads are added for unmatched pad stack layers and connections are added to the design. You can save, I can close this and then save with warnings. Or I just save the test. I should do a save as, close, and then save with warnings, because I need to name this properly. And it's V for via. And then again, by default, we assume it's a circle on the outside. So 100, because it's 1.0 millimeters. And then the hole size is 0.3 millimeters, so 30. And then there's no other special characteristics. It's not a blind via. There's nothing else going on here. And so we just go ahead and save it. All right, now we have one more to come up with here, and this is a fiducial. And I'm going to do it here in the video. I'm going to have you recreate, so everyone should get this part 100% correct on your homework, because you're going to turn it back in, but you literally have to just copy and all of the steps that I'm doing here for the fiducial. So the fiducial, we're going to go here, and let me see if the naming convention here actually talks about fiducials here. It might not, because this is an abbreviated document here. I'll have to double check, but I'm fairly certain, and we'll go ahead and use this, is that we'll use F for fiducial. Fairly certain that that's a standard naming convention, but I'll have to double check on it. I know that the etch that I'm going to do on it is a 3.00 millimeter pad, and I'm going to have a hole size of 1.00 millimeters. And this is a fiducial. So it's set up as a fiducial already. And design layers here. So I'm like, what is it doing here? And what it's doing is it's the way, I had forgotten the way it does its fiducials here. This is actually a perfectly acceptable fiducial that we would do here. The way it's doing it is that there wouldn't be an etch layer on it. It's looking at it as an exposed piece of copper and then the solder mask that you would have then covering it up. And so I'm not going to follow this particular method here because I want the hole drilled. So I'm going to have to kind of go back here and kind of jury rig it. The name is still going to be the same, but I want a hole drilled for my fiducial, and this default one here is not letting me do that. So I'm going to actually, seems weird, I'm going to define it as a through pin. And because I want to drill a hole, and that's because of our particular PCB etcher, actually it's easier for it to recognize a hole drilled. But let me emphasize that, fiducials are not necessarily holes that are drilled. Sometimes fiducials are holes that are drilled, sometimes they're just exposed copper circles, and it's for camera recognition. And the camera we have, it recognizes those holes being drilled better than it recognizes just straight copper. And so that's why we need to have those actually as a through pin here. So we'll do those as one, and then we will do the design layers and circle, and we're going to do the 3 times the radius, or 3 times my diameter. And I think I actually already forgot to do my drill symbol again. So let's go back and take that so I don't forget that. Okay. Whoops. 1 millimeter. Circle, diameter of 3 millimeters. And now I'm going to have to define all of these layers, even though for fiducial, you're really only typically doing the top layer. But just so I don't get an error when I try to save this, I have to define all of these layers. But typically at fiducial, again, it's only on the top layer. Now I am going to still do a solder mask layer. I am just going to go ahead and put that solder mask, though, right up against the copper, because the copper etch is not really being used for any actual mounting purposes. It's just being used to kind of isolate the fiducial itself from the other aspects on the board. So we can, if the solder mask goes a little bit over the actual copper, it's not going to be important for us at all. So I'm just going to set that at the same diameter there. And then I'm going to save that. And now we have a fiducial defined. All right, so what I think we're going to work on next here is we're going to go ahead and start bringing this all together. I know we still have only done kind of component wizards for actually getting footprints of components. But I'd like to move on to actually starting to do some simple layouts, because there's quite a bit of process now to combine all of this information together. And so we're going to start with a very simple layout where we don't have mounting holes, we don't have fiducials, we don't have vias. We're going to do a very simple circuit. We're going to lay it out, do all the footprints and everything, and then we'll go on a more complicated circuit. Then in the next week or two here, we'll also start the soldering project, and that project has to be done on your own time, and I will be having my lab technician first off etch all the boards for you, because this first one is kind of I'll make some videos of assembling the board, but then she will be present at specific times in the lab if you need some assistance with soldering. I will show you how to solder through some videos, but honestly, until you start doing it yourself, that's how you're going to learn how to solder.